Yo, everybody, what's up? Welcome to Brain Flux. So, today we're gonna get into some more concepts and we're gonna look at how to determine the limit reagent, how to calculate the mass of a salt crystal, and determine the percentage yield of that salt crystal. So, we're gonna look at a question which came in the ECZ 2025 GCE paper to answer all these questions. So, let's get into it. The question reads that crystals of copper to sulphate can be prepared from a reaction of copper oxide with sulphuric acid. In an experiment, 7.95 grams of copper oxide is mixed with a solution containing 7.35 grams of sulphuric acid. And part A of the question reads, construct a balanced chemical equation for the reaction. So let's write that. Okay, all chemical equations have reactants on the left hand side and products on the right. So as an example, this should be read as A reacts with B, the plus means reacts with, to produce AB. If there was another product, let's say CD, it would be NCD or something like that. So first of all, we need to identify the reactants. So that's copper oxide, and we know that it's in a solid state, reacting with sulfuric acid, which is a solution, and all solutions are in aqueous state, basically the liquid mixed with some water. And this is going to produce copper to sulphate and water, because whenever we have a basic oxide reacting with sulfuric acid, it's going to give us a salt as well as water. So this right here is going to be the reaction equation. So we're just going to put aqueous there since it's a salt solution, and L for water, meaning that it was produced as a liquid. Then next thing, we're going to try to balance this up. So we're going to check the number of atoms in the reactant side and compare it to the number of atoms in the product side. So one copper there, one copper there. We have 1 plus 4 oxygen atoms, and we also have the same this side. We have 2 hydrogen atoms and 2 hydrogen atoms there. Therefore, the equation is balanced. Okay, part B of the question reads, determine the limiting reactant. So a limiting reactant is just the reactant which will make the reaction stop because it's in short supply or there's a shortfall of it. Okay, part B of the question is asking us to find or determine which one is the limiting reactant. So in this case, we have only 2 reactants, that's copper oxide and sulfuric acid. Now, in order for us to know which one is the limiting reactant, basically the one which is in short supply and hindering the reaction from proceeding, we need 2 things. First of all, we need this balanced chemical equation as well as the number of moles for each individual reactant, right? Now, the reason why that's important is going to be seen very soon. So first of all, let's just calculate the number of moles for each. So let's get copper oxide, right? Let's calculate the number of moles in it. We know that the number of moles is equal to the physical mass over the molar mass. Now the physical mass was given in the question, and that was 7.95 grams over the molar mass. You need to use a periodic table to find that. So what's the mass of copper? That's 64. What about the mass for oxygen? That's 16. And then if you plug this into a calculator, that's giving you roughly 0.9935375 moles of copper oxide, right? Now let's find the number of moles in sulfuric acid. So the number of moles is equal to the physical mass, which was given as 7.35, and then divided by the molar mass. So since there are 2 hydrogens, 1 times 2, and then plus sulfur, which is 32, plus oxygen, since we have 4 there, times 16, which is 64. plug all that into a calculator, and you're going to get roughly 0.075 moles of sulfuric acid. Okay, now the reason why these two values are important, let's compare them to what we have in the equation. So since this equation is balanced, it's telling us that 1 mole of copper oxide needs to react with 1 mole of sulfuric acid to give us 1 mole of copper sulfate and 1 mole of water. So basically speaking, we're saying 1 and 1 needs to react to give us one of those. So this means that the values or the number of moles of both of these is supposed to be equal. But in this case, we've already seen that they are not. So which one is the smallest value? That's 0.75. Therefore, it's the one which is hindering the reaction, because only 0.75 moles of copper oxide needs to react with 0.5 moles of sulfuric acid. So therefore, sulfuric acid is the limiting reagent. Okay, part C of the question now reads, hence calculate the mass of copper to sulphate crystals expected to be produced. And whenever a question says hence, it means you need to use the results that you got from your former calculation, or basically the question that you answered. Okay, now here, one thing to know, they're asking us to find the mass of copper to sulphate crystals, not just copper to sulphate. So we also need to include the water of crystallization during the calculation. Okay, let me show what I mean. Okay, so now we have copper to sulphate crystals. So copper to sulphate crystals are written like that. Okay, the first step, we need to find the mass of copper to sulphate. Just copper to sulphate, not the crystals. So how are we going to do that? If we check our balanced equation, we know that this is 1 to 1 to 1 to 1. So yeah, that means it's very easy. So here, one thing that we're supposed to do, we need to check the limiting reagent. And since we found that it was sulfuric acid, we get the number of moles of the limiting reagent. So which means 0.075 moles of copper oxide reacts with 0.075 moles of sulfuric acid, and that produces 0.075 moles of copper sulfate as well as 0.75 moles of water. But don't think the water of crystallization is coming from this water which is being produced right here. Okay, this is where we need to say that the mass is equal to the number of moles multiplied by the molar mass. So in this case, the number of moles, as we said, was 0.075 multiplied by the molar mass, and this is going to be copper, that's 64, plus sulfur, which is 32, plus oxygen, which is 16 multiplied by 4, which is also another 64. Okay, multiplying all of these would give grams of copper sulfate, right? Okay, now this is where we need to find the water of crystallization. So we can tell from this formula that for each mole of copper sulfate, we need 5 moles of water, or basically the water of crystallization. So this is what we're going to do, right? We're going to say that if 1 mole of copper sulfate is always attached to 5 moles of water, then since we have 0.075 moles, 0.075 moles of copper sulfate, how many moles of water are attached to it? So let's just cross multiply. I think let me replace this with an n. Okay, we cross multiply, and then we're saying the number of moles is equal to 0.375 moles of water, right? Okay, now since we have the number of moles of water, we can say that the mass of the water of crystallization is equal to the number of moles multiplied by the molar mass. So the number of moles, which is 0.375, multiplied by the molar mass, which is 18. That's going to give us 6.75 5 grams of water of crystallization. So what we need to do next, we need to add these two masses. The mass of copper sulphate itself plus the water of crystallization which is attached. So we're saying that the mass of the crystals is equal to 12 plus 6.75. Okay, let's add these. That's going to give us 18.75 grams of copper to sulphate crystals. And that's how you find the mass of crystalline salt. Okay, now for the last and final question, which is part D. It says on crystallization of the solution, 16.3 grams of crystals of copper to sulphate were obtained. So now they're telling us to calculate the percentage yield. Okay, the percentage yield is actually found by dividing the actual yield, which is the one specified in the question, by the theoretical yield, which is the one that we found in our previous question, and then multiplying it by 100%. Okay, so now let's just plug in the figures. We know that the actual yield is 16.3. Then the theoretical yield, the one that we calculated, was 18.75. Then we're going to multiply that by 100%. So if we plug all that into a calculator, we're going to get 86.9%. That is correct to 3 significant figures. And that's how you calculate the percentage yield. So guys, if you learned anything from the video, please don't forget to like and subscribe to the channel if you haven't already, and share it with a friend who's in need. Friend in need is friend indeed. Okay, success through synergy. Peace, y'all.